Sahanavavatu Sahanam Gunatu Sahaviryam Karavavai Tejasvinavaditamastu ma vidvishavai. Om Shanti Shanti Shanti. Om Samasta Jana Kalyane Niratam Karunamayam Namami Chinmayam Devam Sadgurum Brahma Vidvaram. Sadgurum Brahma Vidvaram. So yesterday we saw till division, and division procedure we did not discuss because it's the same procedure that we are exactly following today. And he states the simplification procedure also, like if we have to do something like 146 divided by, say for example 6, so he says if it is an even number, so you divide by the common factors, the simplification procedure. So that's the same procedure that he suggests. So we'll go ahead with squaring, and squaring there are some interesting techniques, of course nothing new, but again using the identities that we use for squaring. He has he has changed it a bit for easy computation. So these are the terms varga and kriti we use for square. Vargamula is square root, and mula mainly it means root. So we'll see the first method in squaring. So this is the general method that he says. So if we is directly starting with this number 297. So if it is a 3-digit number, how will we do it? So 2-digit number, if we understand 3-digit number, then we can understand the 2-digit number also. So I'll just go step by step. So I will put these colors 20, 2, 9 and 7. So it is 297, but since the 2 will appear some other places also, so I have put a red color for 2. And first we will square 49. So directly I have written that 49. You can just see how it is positions, and later on you can write it down maybe. And then what we do is 7 into 2 into 29. So this 2 is 2 times. This 2 is not the 2 from 297.
2 times of last number.
ये जो है इसको 29 into 7 उसका double. That is this 2. So that is why I have written this 2 in black, because this 2 is not this 2. So to remove that confusion, so 7 times 2, 7 times 29, 7 into 29 multiplied by 2, and we write it down in a slide. We leave one space below 9 and we write 406 as the answer. So this is the second step. And third step, what we do is we take this number 9, this middle number 9, square it. So 81. Again I have to leave one space below 6 blank. And then we write square of 9. And then we go to the next 2 digits, that is 2 and 9. So I multiply 2 and 9. Then I double it like I did here. Here I did 29 into 7 and then double. So 2 into 9 multiplied by 2, double of that, 36. Again I am leaving one space below 1. One space is left below 1. And next would be this last digit number 2. 2 square, which is 4. Again I leave one digit number, one digit below 6, and then we just add. So this would be the total. So as we can see here, see it is coming like this slanting. That is, here in the units place we have to leave one digit, one space below that. Here again below the unit space of this number, again one space here and one space here. Or if we write it in a box form, it will be like this step by step. First we square 7 and we write 49. Then we do 7 into 29 and then double it. So 406. So we will leave one square at the end. And then we will square the middle digit 9. 9 square is 81. Then again we will do these two numbers, will multiply and double. So again I have to leave one more space here. and then square of the last digit. So this is a general method that he suggests, which can be used for any number squaring. Any number squaring, not specific to any this thing. So for 4 digit, it will go ahead. Now we can try it out with this number. So 345, this is just some number I chose, so that we can work it out. 345. So we can try doing the same process here for 345. Into 5, 170, 170, 40, 4, 2, and then 4 square, 60, and then 3 times 4 multiplied by 2, 3, 4, then 3 square will be 9. Correct. So 5, 2 plus 0, 2, 6 plus 4, 10. So 1 is carried over 10. 3 plus 1, 4 plus 1, 5, 9, will be 11. So 1, 1, 9, 0, 2, 5. So this is a general method that he suggests. I hope this is clear. And then he goes ahead and discusses a plus b the whole square. So he is not mentioning anything specific about a minus b the whole square, but then if you put that, it is the same thing, like instead of plus b you put a negative value. That also he explains, and a square equals, a square minus b square equals a plus b into a minus b. But here he does one more thing. He takes this b square to the right side, and he says this way we can do squaring. This is another way. Now how does this particular thing help? I don't think at least in our school days we had tried squaring numbers like this. We were using a square minus b square. But how to find square of a number using the other thing, and where it would be useful. So if we can just think of some numbers, say for example I want to do 49 square. 49 square. So 49 square is like my a square. Right? So here I don't know any value for b. So it is up to me what value for b that I want to choose. I can choose some number which is convenient to me. Any number which is convenient to me. So if I choose 1, the advantage I get is 49 plus 1 becomes 50. 50. Multiplying by 50 will be easy. 49, this will become 49 minus 1. So a 2-digit number multiplied by 50 plus b square. b is 1. So plus 1 square. Right? So I have chosen here, this is my a, this is my b, this is my a, this is my b, and this is my b square. So since b is small, squaring that is simple. And since we have chosen 1, this becomes 50. 50 multiplied by 48, that is also not difficult. Plus 1 square. This becomes 2400 plus 1, 2400. Yes. So instead of 1, if we choose anything else also, we will get the result. We can choose 2, 3, 4. But the problem is, if we choose 2, it becomes 51 into 47, which is again little time consuming. So we have to intelligently choose the numbers here. Can we think of any other numbers instead of 1, but still we can do it faster? 9, yes. So if we use 9, this will be 49 plus 9 and 49 minus 9 plus 9 square. So the advantage that we get here is we get a 58 multiplied by 40. 49 minus 9 plus 81. So 58 into 40 might be easier for us, because 58 into 40 means we have to just double and double. That will be 58 into 2 will be 116. Double of that will be 232 and 0 plus 81. This becomes 2401. So even we can take 9 in that case. So depending on this number, we have to intelligently choose what value for b we have to take. In fact, many people who do mental calculation thing for squaring, they use this particular method. There was a boy who came to our camp last year, Raghavendra. He does mental squaring for 4 digit, 5 digit, 6 digit numbers. He is able to do squaring mentally. He uses this technique. So this way of squaring, it really helps him. Like even Shakuntala Devi or people like them who do shows like that, mental calculation technique, they use these kind of this technique. So this is just this particular thing, this b square we are taking to the other side. Right? We want to try out one question. Let us try 39 or 38 square. So 38 square. 38 square. One, 444. So did you take 2 here or anyone took 8? 8 is also possible. If you take 8, it will be 38 minus 8. So multiplication by 3. But if it is multiplication by 40, 4 means you have to just double and double. Into 4 matlab 2 into 2. So into 4 के लिए double 2 बार लेंगे तो हो जाएगा. So this will be 40 multiplied by 36 plus 2 square. 36 into 4, 144, 1440 plus 4 will be 1444. So अगर ये एक 3 digit number है, suppose, say we have something like 129 or 128, or say let us take a smaller number for the time. Let us take 122 square. So we can take here 122 plus 2 multiplied by 122 minus 2 and then plus 2 square. This will be 124 multiplied by 120 plus 2 square. Again multiplication by 12. Yesterday we had seen multiplication techniques. How we can split 12. Whether we have to split 12 as 8 plus 4 or 12 plus 2, or we can take 12 as 1 and 2 and change the positions accordingly. Yesterday's multiplication. So any of those techniques can be used here, and then we can get the answer and then add 2 square. So this will be 1240 plus 248 will be 1488 plus 4. This will be no, I went wrong. Sorry. This will be 2480. This will be 1480 plus 4. So 14484. Okay. So this can be done for. This can be done like this. So this is another squaring method, and in the next method we don't find in Coolbrook's translation. Okay, this is just an explanation. The next method, this method we don't find in Coolbrook's translation, but in Kriya Brahmatri and all we find it. So this can be one of the interpolated formulations, right, sir? Heroor, sir. So this one, what maybe one of the commentators they added is a plus b the whole square we know as a square plus 2ab plus b square, and a minus b the whole square is a square minus 2ab plus b square. So what we are trying to do here is we are trying to express a plus b the whole square as a minus b the whole square plus something. So what is the advantage of doing it? So if you take a plus b the whole square, this will be equal to, if we want to write it, a plus b the whole square equal to a minus b the whole square plus how much will I get, how much should I add so that it becomes this. So we are adding 4ab to that. That is how we get this. So 4ab, when we add this minus 2ab plus 4ab becomes plus 2ab. So this turns out to be a plus b the whole square equals 4ab plus a minus b the whole square. Now what is the advantage of doing squaring like this? So let us try to, it's again an intelligent way of splitting. So let us look at this example of splitting 47. So how should we split these two numbers? So here I am taking, this is what I felt is easy for me, because if I take 25 and plus 22, 25 and 22. So my a is 25 and b is 22. So when I take a as 25 here, it's becoming 100. 4 into 25 into 22. So here my calculation is easy. 4 into 25, 100. 100 into 22, 2200. And a minus b is also a small number. 25 and 22. Difference is 3. So squaring 3 is not difficult. So again 3 square. Right? So this way of splitting, this of course we have to know the square of a minus b. Then this is easy. Otherwise उसके लिए भी squaring करना पड़ेगा, additional process. But if we can split numbers in such a way, then a minus b would be a smaller number. You can even think of some other numbers above 50. Say suppose we want to do it for 59. 59. How would you want to split 59 as? If you take 50 and 9, that is also fine. So if you take 59 as 50 plus, this is plus 9, so it will be 4ab. So 4 into 50 into 9. This is fine. Is there any other way of this? And of course the difference here, but you will face a problem here, because a minus b is 41. So unless and until you know 41 square by heart, it is a challenge. So we have to look at these two numbers which are closer to each other, 30 and 29. Okay. So 30 and 29. So if you do 4 multiplied by 30 multiplied by 29. So again we have to do 29 into 4 multiplied by 3. 29 into 4 or 29 into, that calculation will be there. 25 and 34. So 59, if I split as 25 and 34, again the advantage is 25 into 400. We get 100. So if we can try to get numbers here like 25, 50 or 75, then we can get 100 or 200 or accordingly 300. So like that we will start getting numbers. So then when we choose this, of course the difference should be known. So here if it is 25 and 34, the difference is 11. So 11 square is not difficult. A minus b the whole square will be 11 square. Is that okay? So yes, 9. So using, if we have to do 9 square, oh, 34 and 25, sorry, 9 square, 34 and 25, 9 square, not 11 square. Yes, so this again we can do these kind of problems, these kind of ways of squaring, especially in 7th standard and all, where they can do these things mentally. So the squaring can become a mental exercise, but how to split this number intelligently is some task that we'll have to figure out with practice. Okay. So next is the rule for square root. So this is the modern day procedure for square root, and this is what is mentioned in Lilavati. So we will see how it is same or different, or what is the similarity. So the first thing in squaring is, okay, I haven't put a line here. In finding square root, we have to start grouping from the right sides into groups of 2. So this will be one group, this will be the second group, this will be the third group, in groups of 2. And after the first, in this we will have to see which is the perfect square. Perfect square means 1, 4, 9, 16, 25, 36. All these are perfect squares. So which is the perfect square less than or equal to 8? So it is 4. So I subtract that 4. 8 minus 4, I get 4. And which is the square I subtracted? 4. So I take the square root 2. Square root of 4, 2. I double it and write 4. Then I just write down 8 and 2 as it is. And then this 4 I have to write down here 4. And I have to multiply by some number which I will subtract here, and I will get a remainder. And this number, from this I have to square this number. 9 square is 81. Now this might be initially a bit challenging, because what number should we choose here? Should we choose 9 or should we choose 8? Or can't we choose 10? Because 4 into 10 is 40. 48 minus 40 is also possible. So why can't we choose 10? So what if we choose 10? Suppose we choose 10. So then 48 minus 40 would be 8. 82. 8 and 2 you write down. And then 10 square you will have to do. So 82 minus 100. I repeat. Whatever number we are multiplying here with 4 into 9, that 9 has to be squared again. And 4 9s are 36. So 48 minus 36 is 12. Write down this 2. So from 122 we have to square this 9. Then we will get some remainder. If I take 10 here, 4 into 10 is 40. So 48 minus 40 is 8. 8 and 2, 82. So 10 square is 100. So 82 minus 100, we will get a negative number. So we can't take 100. So we will have to take less than 10, we try it with 9. So 4 9s are 36, what is left is 12. Write down to, so 9 square is 81. So 122 minus 81 we get 41. And then we write down the remaining 2 digits, 0, 9 also. Now this 9 with which I have multiplied, I have to double that and write here 18. So 49, and see how 18 is written. 1, 8 is here, and then you add it like this. So it is like 40 plus 18, 58. This is the quotient part that we are writing here, quotient. So 58, and then this number 58, I have to multiply with some number, and I have to square that number again in the next step. So I have to choose a number 58 multiplied by some number which will be less than 410. So when we do 58 into 7 we get 406. What is left is 49. And that 7 square when we subtract, 49 minus 49, 0. So now here again our process is not complete. We are multiplying. Earlier we multiplied by 9. We took the double and wrote here 18. So here we are multiplying by 7. So we write the double 14. And we just add them. But see how 14 is written. Again one step is here. So it is like 580 plus 14, 594. So here in the quotient, every time we have doubled, we have taken the double and written here. So take half of this, that will be the square root. So half of 594 is 297. This is the procedure that today it looks little complicated, but when we compare this with the modern day procedure, we will come to know why they were doing it like this. So this is the modern day procedure. So what we do here again, it is the grouping thing. First group is 0, 9, second group is 8, 2, third group is 8. So here, or rather this is the first group. So first group, how many, which is the perfect square less than or equal to 8? So it is 4. So I do 8 minus 4, 4. And I take the square root of 4. Instead of making the double, I will directly write 2. Earlier we were writing the double here, 4. So instead of doing that double, directly we are writing here 2. This is a modern day procedure. And we write down 4, 8, 2. And 4, with that we have to multiply a number 9, some number, so that it is less than 482. So we do 4 into 9, 441. Sorry, 49 into 9, 441, and then we get 4109. Now, why they were doing it like this? So here if you see, here they are doing 4 multiplied by 9. So it is like tens place multiplied by units place. And then 9 into 9. So instead of directly doing 49 into 9, 49 into 9, like 9 into 9, and then 9 into 4. So that is what they are doing. 9 into 4 they are doing first, then they are doing 9 into 9, which is 9 square in Lilavati. But today we are directly multiplying 49 into 9. So perhaps this is the mental procedure that the students used to do at that particular time, and that is what he has explained here. So today we do it 49 into 9 is 441, and again the remainder is 41. Write down 09 and then 5. Okay, this 29 again in the modern day procedure, whatever is here, this 29 we write, we take the double of that 58, and we, or sorry, not 29 is double, it is 49. To this, what number we are multiplying? This 9, we have to add that 49, 9 to 49. So 49 plus 9 is 58. That step I have missed to write. So here, what we are doing? Here we are doing this. What is that? 2, the double of 2, and after we complete this process, then we get 49. 49 plus 9 is 58. 58. With that, some number we have to multiply. We have to take a digit, and that only we have to multiply 7. So if it is 6, then it will be 586 into 586. That number we get like this. This is the modern day procedure, and in Vedic mathematics by Swami Bharati Krishna Tirthaji, there is a different procedure for doing this, which I am more comfortable with, even because that becomes like little more faster. But this is the comparison between modern day and the earlier days procedure. So I think I must have written one more. Okay, one more example. We'll just look at one more example just for better clarity. This example is not given by Bhaskara. This I have just taken down some example. 1, 2, 9, 9, 6. So again we start grouping from the right side. So 9, 6 is one group, 2, 9 is one group, and 1 is the last group. So which is the perfect square less than or equal to 1? It is 1. So 1 minus 1, 0. Whatever we are writing here, we double that and write here 2. Again we write 2, 9. So now this 2 multiplied by some number should give me a number here. So 2 minus 2, that subtraction is possible. Then we write 9 here, 9. And then this 1 we square it and subtract. Right? So it is like your 21 into 1, 2, 1. 21 into 1. That is what. So here we are actually subtracting 21. 29 minus 21 we get 8 in the modern day procedure. 29 minus 21 we get 8. Here we are doing 21. This 2 into 1, 2, and then we are doing 1 into 1, 1. We get 8. Then we carry down 9 and 6. Then we do, okay, some number we have taken. Here we have taken 1. So that double of this number we write here 2, but leave one space here. So we get 2 and 2. So it is like 20 plus 2, 22. And again here we got 896. So 22 multiplied by some number, and I should be, so it is like 22, 2, 2 dash into dash. So whatever number I take, 2, 2 and some number, I have to multiply by that very number. That is what I have to do. So here when we choose 4, we are able to do 22 into 4, 88, this is gone, and then what remains is 16. So 4 square is 16, we get remainder 0. So every time we have an 8 also, this 4, double of that will be 8, leave space. So 220 plus 8 will be 228. So all these are doubles, so we will have to take the half, so it will be 1, 1, 4. So this is the procedure for square root that is explained here. Now for cubes, there are these are the terminologies given in Ganesha Devakinya's commentary. We can see some interesting ways of expressing powers. So Ghana is cube, Varga Varga. So when we do Varga Varga, Varga is square. So square of square. So if it is like a square, Varga Varga. Okay, so this will be a to the power of 4. So that is the fourth power. Fourth power. Varga Varga will be fourth power. So fourth power they are naming Varga Varga because of this. Varga means square, again square of that. Next is Varga Ghana or Ghana Varga. Again Varga Ghana or Ghana Varga. A raised to 6. So that is sixth power. Next is Varga Ghana Dhata. Dhata, we had seen this word, I didn't explain it much, I was just running through that terminologies. Dhata means product. Dhata. Dhata means product. So Varga Ghana Dhata. So Varga is square, Ghana is cube and product of that. So when we multiply it like this, so by the rule of exponents, yes, so this will be 2 plus 3, a raised to 5. So the reason they have used, because this dhata is used, that means whatever is written here, we have to multiply it like this. So Varga Ghana Dhata. Again if it is Varga Varga Varga, so it is square, square and square. 2 raised to a raised to 2 Varga, again Varga. So this will be a raised to 4, the whole square will be a raised to 8. So Varga Varga Varga. So that is the 8th power. Next is Varga Varga Ghana Dhata. Let us just write it down. Varga Varga Ghana Dhata. So when we multiply, this will be a raised to 2 plus 2 plus 3. That will be a raised to 7. This is how we can express, there is another term for 7th power. 9th power will be Ghana Ghana. Cube and cube. A cube and cube. That will be a raised to 9. 9th power. This is how, these are a few terminologies, of course, given by Ganesha Devakinya in Bijaganita. And these are the formulae, 3 formulas that we use for cubes. This is the common thing that we learned today. A plus b the whole cube is a cube plus 3a square b plus 3ab square plus b cube. And the second formula is same like the first formula. It's just that in these two, 3ab is taken common into a plus b. 3ab common and multiplied by a plus b. So it is the first formula only. In the second and third term, what is common in the second and third term? 3ab. So we take 3ab. Inside the bracket there is one a here, there is one b here. So a plus b. So if you open the bracket, it will be 3a square b and 3ab square. So it is the same thing. But for convenience for certain numbers and all, we can maybe when a plus b is 10 or multiples of 10, say for example. if a plus b is 10 or multiples of 10, say suppose it is 7 and 3, so then 7 plus 3 10, so then this becomes 10, so into 10, so it becomes easier. And okay, so these are the two things, and then he states this rule, that is, if you have to cube a square number, how can we do that cubing? What he says is, we will have to take that, say for example, let us take 4. 4 is a square number. We have to find out the square of 4. So he says, you take square root of 4, which is 2. Cube it, 8. And then square it, 64. Instead of doing 4 into 4 into 4, saying since 4 is a square number, so this formula it will be useful when you have to find out the cube of a square number. So a square, it is already a perfect square. So you want to find out the cube of say 9. Cube of 9. So since 9 is a perfect square, we will take the square root of 9, 3. Cube that, 27. 3 cube 27, and then square that, so 27 square, 720. The advantage that we get here is when we take the square root, the number becomes small, and we have to cube it. So we have to cube the smaller number. That is the advantage that we get here. We can try 16. 16's cube. So we take the square root of 16. 4. Cube of 4. Again can be done like this. So 64. Again square of 64. It will be to the 4096. So when we have to do square of 64, it is relatively easier. When we have to do cube of 4, this will be easier, and square of a 2-digit number will be easier. So this is another way that he suggests for mental cubing. So these 3 formulae is discussed, and this is the process. And for cubing in Manoranjana, in another commentary, you have to cube 125. So here, as we can see, till now you are following this way of arranging numbers. You are writing numbers like this, slanting. But here, we are starting from the left side with 1 instead of starting from 5. So the pattern has changed. This way we have to arrange. So first we cube 1. Then what we are doing? Square of 1 tripled and multiplied by 2. What does that mean? Square of 1 tripled. So 3 times 1 and multiplied by 2. So 1 tripled square of 1. Let's just write it down so it will be easier. Square of 1 tripled and multiplied by 2. So this is nothing but our 3 into a square b. In the formula a plus b the whole cube, a cube plus 3a square b plus 3ab square plus b cube. So here we have done a cube first, 1 cube, a, b. So a cube, 1 cube, and second is square of 1 tripled. So square of 1 tripled and multiplied by 2. Why multiplied by 2? Because 2 is the next digit, 2. And why tripled? Because it is there in the formula 3 times. And then we write 6, but again we leave 1 space here and write 6. Next will be square of 2 tripled and multiplied by 1. So square of 2 tripled and multiplied by 1. So if I just rearrange it, it will be 3 into 1 into 2 square, which is nothing but 3ab square. that is what, this is our A and this is our B. So we are doing 3AB square, so we get 12. Again, see how it is arranged. It is going like this, slanting. So 1, 2. And then we have to take cube of 2. So now this is B. Cube of 2 is 8. That we write in the end. And then we add all this. Now this is what? This is the cube of, actually this is the cube of 12. This is the cube of 12 cube. Now 5 is remaining. So we take, consider 12 as one number and 5 as another number. Like a digit, if you want, you can consider 12. When we are doing 2 digit squaring, so like that, for 12 consider as one number. Square of 12 tripled and multiplied by 5. So what does that mean? Square of 12 tripled and multiplied by 5. So this is again our 3a square b equal 5. Next would be square of 5 tripled and multiplied by 12. So square of 5 tripled and multiplied by 12. So this is our 3ab square. Then we do b cube. Again the arrangement is very important. So as you can see, 1728, leave a space here this side and write 2160. Again leave a space there, write the next one 900, leave a space and write 125. When you add all that, you will get the square of 120, cube of 125. So this method can be reversed if we want to start from 5 and start writing from 11. Okay. Would come back, but basically it is the same rule, same process that we follow in the modern day also for extracting cube roots. It's just that we we don't arrange them in this particular order. Instead, we leave those spaces blank or write zeros and then write it down 1 0 0. The references I have taken was Brooks, Lilavati, Brooks translation. Okay, till the projector comes back, I'll just mention the terminologies. So, Bhinna Sankhya, Bhinna means different. Bhinna is fraction. Bhinna is the word used for fractions. So, next topic that we discuss is fractions. And Bhagajati Chatushtaya. So, 4 modes of reducing fractions to a common denominator. So, if we have to add fractions, 1 by 3 plus 1 by 4, we have to add, we have to get a common denominator. So, how do we get a common denominator? So, it is the same thing. What he says is, you multiply this fraction by this denominator and you multiply this fraction by this denominator. You will get a common denominator. That will be 4 by 12 plus 3 by 12, and then we can add it as 7 by 12. So that is the method that he suggests. This is this LCM, what is that? Cross multiplication thing. And if it is something else, like instead of 3, we have something like 8. So again, he says take the LCM. That kind of thing. So the procedure for adding squares is not very different. It is the same, adding fractions. But what is interesting is again a few techniques that he uses for operations with squares. Operations with fractions. So those are really interesting. And those were the topics that sir was saying we will cover first, and then we will go on to solving those problems which we left today. Numerator and multiplier. Okay, so this is the verse 29, and the meaning is numerator and denominator being multiplied reciprocally, means 4 is that, and then denominators of the quantity then reduced to the same denominator. So the process is the same, that is, if you are having denominator b, so multiply c by d as cb by db, c into b by d into b, again do that, a into d upon b into d. So that same thing what we did here. Doesn't look very appealing over there, a by b and c by d. Since we are having b here, you multiply b upon b. Since we are having d as denominator here, you multiply d upon d, get a common denominator. Tell me the fractions reduced to a common denominator which answer to 3 and a fifth and a third. Okay, this is another challenge that we find in word by word translation. So if you want, you can just read that verse 30 in Sanskrit in your printout. Verse 30. The fractions reduced to a common denominator which answer to 3 and a fifth and 1/3 proposed for addition, and those which corresponds to 63rd and 14 offered for subtraction and 14 the other way. So these are two different problems. The problem after semicolon is a different one. So 3 and a fifth. So 3 and a fifth. Fifth means 1/5. 3 and 1/5 plus 1/3. This is one problem, and the other one is a 63rd. So 1 by 63 and a 14. 1 by 14. So what is the difference? And which corresponds to a 63rd and 14 offered for subtraction. So what will be the result? So here again, for this process it is basically it's the same thing that we do. So this will be our 15 plus 1, 16 upon 5 plus 1 upon 3. So we multiply this fraction by 3 by 3 and this fraction by 5 by 5, we get 48 upon 15 plus 5 upon 50. So again denominator is common, so 48 plus 5 is 50, 3 upon 50. This is nothing new, this is the same thing that we do. For 1 by 4 in minus 1 by 63, either we can directly do it, or the other way is, as 14 and 63 are multiples of 7. So here we can take 1 by 7 as common. 1 by 7 as common. Because 14 and 63 are multiples of 7. So 1 by 7 into half is 14. 1 by 7 into 1 by 9 is 1 by 63 and difference of that. So we have to just again take the LCM. Take that outside. Again do this operation. So here again multiplying this one by the other denominator. So this will be 1 by 7 of 9 by 18 minus 2 by 18. So this is 1 by 7 minus 1 by 7 multiplied by 7 minus 9 minus 2, 7 upon 18. This will be 1 by 18. Here we had 1 by 2 minus 1 by 9. 1 by 2 minus 1 by 9. So this 9 I am multiplying in the numerator and denominator by 9. Okay. 1 by 7 we have taken common outside. So what is left inside is 1 by 7 into how much is 1 by 14? Half. Minus 1 by 7 into how much is 1 by 63? 7 9 the 63. So 1 by 9. You wrote some other number instead. So that way we can solve this.
Sir,
Yes.
in our copy, this is not 31.
Because of I think that a square plus b square equals 4ab plus a minus b the whole square. That verse might be there in your this thing. I told you one verse Bhaskara has not. I mean, in Coolbrook's translation it is not there. So that verse might be the verse that is appearing over there. So that is the difference in the reference. Anyways, in today's printout, sir has given that in text. You will get the printout by afternoon because it is running into 69 pages. They are giving it for photocopying for all of us. So it will take some time doing the photocopy. So in that, in the end, there is that indexing. Coolbrook verse number 30. In which text it is verse number 31. In some other text it is verse number 32. So like that. So then you can have an easy comparison with that. Sorry? So reduction of fractions. Okay, it's a quarter and a 16 and a fifth. If you want, you can read that next verse. So this might be verse number 33. Verse number 33. So verse number 31 explains the multiplication of fraction. That is, we have 1 by 2 multiplied by 1 by 4. You just have to multiply the numerators and multiply the denominators. So for multiplication and division, you just go on multiplying. So that is what is explained. If you want, you can just go through that verse number 31. Your verse number 32. Sorry, in your printout verse number 32. Yes. So in your it will be 32, right? 32, and 33 would be the example. Yes. So example, we can just go through that example. Again, we can you can read the Sanskrit words. Those who are more comfortable in Sanskrit, and those who are not, we can look here. A quarter of a 16 of a fifth of 3/4 of 2/3 of a moiety. So moiety is a term which is used for half of a drama. Was given to a beggar by a person from whom he asked alms. Tell me, how many cowrie shells did the miser give? If thou be conversant in arithmetic, which reduction terms of subdivision of fractions. So this, I think in Sanskrit you get some, maybe it comes like like a humorous thing, like a miser is giving. I don't know. I'm not the humor or some other this thing that is embedded in that shloka. So a person is begging for alms and then you are giving alms. How much is he giving? So the answer would be really interesting. So here it is a quarter of a 16. A quarter of a 16 of a fifth of 3/4 of 2/3 of half of a drama. So this, we started off with the terminologies, money terminologies in the first slide. We will go to that. We will first see what is the fraction here. So it is 1 upon 16 into 4 into 4, which is 64, into 5. There will be 1, 2, 64 into 5. 320. So that will be 64 into 5 will be
180.
Did I miss out any fraction? A quarter of a 16th of a fifth of 2/3 of a moiety of a drama was given to a beggar by a person from whom we asked now. Tell me how many cowrie shells. I think in the typing thing I have missed some fraction. It is verse number 30. Okay. Quarter of 16 of a fifth of 3/4 of 2/3 of 1/2 of something. Okay. So this is the okay. We will go to the money terminology. So then we will. This was the of a drama. So how many cowrie shells were given? So that is the conversion asked. So this is, I suppose this is drama, right? This one drama, and this would be cowrie shells. So I am thinking where
That product is 1 upon 16.
Oh,
correct?
So correct. So we cancel the numerator. So it will be 6 upon 1280. So this, when we take the money transaction.
No, sir.
No, we don't. If you don't cancel, we don't cancel it as 6
Then
upon.
product by 4.
So here, when we look at the money terminologies, here, if you multiply this is 16, 256, 256 multiplied by 220 into 4. So this will be 1280. So this multiplication, when we do this multiplication, 16 into 4 into 20, we will get 1000. Sir.
6
Yeah.
6
divided by
6 divided by
7,600.
680.
Okay. 6 numerator when we don't do, so then 4 into 6 will be 16, 256, and then we have 5 and 10, correct? 2560. Now into 3. Into 3. So this will be 18, 16, 7. 7680, right? 7680. 7680. So when we simplify this, it becomes 1 upon 280. So it becomes 1 cowrie shell he has given. So 1 out of that much drama. So that will be 1 cowrie shell. 1 by 1280 would be 1 cowrie shell. 1 by 1280 of a drama would be 1 cowrie shell. Single connection. 20 talking is okay. I copied this here. So we will do 6 upon 7680, and then we simplify, we get 1 upon 1280. Okay, so 4 into 16 is 4. Okay, this is another interesting rule that is given in fractions, and I think if you look at the examples, then it would be more interesting. That is, We'll look at the example and then we'll look at the rule. So the question is like this, say how much is 2 and a quarter and 3 less a quarter are when reduced to uniformity if thou be acquainted with fractional increase or decrease. So you can just, I think this will be verse number 35, verse number 35. Again it is English is not there. So 2 added to a quarter, how much will be 2 and a quarter and 3 less a quarter? So again it is 2 added to a quarter and how much is 3 less? Okay, this is another same example like fractional rule. I was thinking of this example, the next one. 35th in the printout. School group. In this printout that is given. 35th note. This one. What is that? Which verse? This one, okay.
There is constant 3 plus 1 by 4. It is not plus, it should be minus.
Okay, this is 3 plus 1 by 4. Then it will be 11 by 4. So this has to be plus. This one, here.
Minus.
This has to be, so 12 minus. This has to be minus. Okay, here there is a typo. So here in rule verse number 35, he gives 3 questions. So these kind of questions would be really interesting to solve. And we'll just see how much is a quarter added to its third part with half of the sum. That is, we have a quarter added to its third part, means 1/4 into 1 by 3. If you want, you can read that Sanskrit verse first. This will be verse number 36. Verse number 36. So a quarter added to a third of its quarter and with half of the sum. So this whatever is that sum, that will be again 1/4 into 1 by 4 into 3. Half of that added to that. So what will be this one? This will be plus. 1 by 4 plus this entire thing, half of that. So how to add or how to do these kind of problems? So we can just try using our regular method and see what answer we are getting and how much time we are taking, and we'll see Bhaskara's method, what method he gives. So if we have to do this, then normally we'll do 1 by 4 plus, or we can take here 1 by 4 common, and 1 plus 1 by 3 plus, here also again you can take 1 by 4 common. So 1 by 4 into 1 plus 1 by 3, and you have a 1 by 2 also, right? And in both the terms we can take this and this common, that is 1 by 4 into the bracket 1 plus 1 by 3, that is this term and this term, which is common. So into 1 plus 1 by 2. So here we have to do 1 by 4 into 3 plus 1, 3 into 1 plus 1, 3 plus 1, 4 by 3, and 2 into 1, 2 plus 2, so 3 by 2. So it will be 1 by 4 multiplied by 4 by 3 multiplied by 2 into 1 plus 1, so 3 by 2. So 3 3 cancel, 4 cancel. What is left is 1 by 2. So here the rule that Bhaskara gives is really interesting. He says is, let us take these. Now what are the fractions we have? A quarter added to its third part with half of the sum. So 1/4, 1 by 3 and 1 by 2. So these are the three fractions that we have. So let us write down 1/4 added to 1/3 and then that whole thing half of that. We are just writing down those fractions. And what he says is, this is what you have to do. You have to write down this 1 multiplied by 4 plus 1, 5. Quarter and how much is a quarter? Okay, the quarter is added. Quarter added to its third part. Quarter added to its third part and then 1 by 2. So it says this is your initial amount, a quarter. This is your initial amount, and then here we have to do 3 plus 1, 4 by 3. So we get this fraction. Take the next fraction, 2 plus 1 by 3. So we get 3 by 2. Just multiply them. So we get the result. Okay. This is our 1 by 4 is the initial thing that is given. That is a quarter added to 1/3 of its part, and that whole sum is added to 1/2. So a quarter, and then so this is the initial thing. Then what we have to do is we are writing 1/3 and half. Right? So these are, so quarter is saying this you multiply by 3 plus 1 upon 3, and then you do 2 plus 1 upon 2 and multiply. So 1 by 4 into 4 by 3 into 3 by 2. So we get this particular result. Okay, the entire thing. So you want to write 1 by 4 plus, okay, below that. Okay, 1 by 3 and 1 by 2. Okay.
Now 1 is the numerator, 4 is the denominator. 1 is the numerator, 3 is the denominator. 1 is the numerator, 2 is the denominator. Here we are adding. So write 1 as it is without any change. Then you have multiplied 3 plus 1. Okay. Then 2 plus 1. 2 plus 1. 4 into 2 into 2.
Multiplied by the denominators, 4 into 3 into 2. So if we take any other variables instead of this, then that becomes the formula. So we write down this one first, a into the bracket c plus d into the bracket e plus f divided by multiplication of all the denominators. So b multiplied by d multiplied by f.
So in this case, there is no change in c plus d and d plus c. But we should write it as d plus c only, because as stated in the rule, it is stated that add the numerator to the denominator.
Because in the subtraction it will.
So this should be kept in mind. This is the where the persons who do not know something so wrong. Yes.
F plus e. So this is the same principle that we can think of, and we can just look at the second question and replace these fractions and try to apply this particular rule. So there we have how much are 2/3. instead of 1 by 4 we have 2/3 lessened by 1/8. So it is minus 1 by 8 of them and then diminished by 3/7 of the residue. So basically it is that entire thing. So how much is 2/3 lessened by 1/8 of that? So 2 by 3 into 1 by 8 and then diminished by 3/7 of the residue. So what is the residue? What is the answer for this one? In that you reduce 3/7. So this entire thing again 2 by 3 minus 2 by 3 into 1 by 8, that we have to multiply by 3/7. So again we are taking then diminished by, so this is also minus. So this will be our minus 3 by 7. So here, like sir said, if we don't do D plus C, so here it will be 8 minus 1. Otherwise it shouldn't be, somebody should not do 1 minus 8 over there. So here if we take A is 2. So let us just put in these values over here. So A is the numerator 2 and then D plus C. So 8 minus 1, 7 multiplied by 7 minus 3 is 4. 4 divided by, multiply the denominators. 3 multiplied by 8 multiplied by 7. That will be 1 by 3. That will be the answer. So we can try for the third one. Would you like to try the third one? Fractions. Which are the fractions? Tell me likewise. How much is half? This is half. Less its 8th part. So again it is minus 1 by 8. And then added. So plus. So 9/7 of its residue. 9/7 of its residue. So this will be. So using the same formula. This again will be A is 1 multiplied by D plus C, that is 8 minus 1, 7 multiplied by F plus D. So 7 plus 9 is 16 whole divided by 2 multiplied by 8 multiplied by 7. So this, maybe there were a lot of practical cases where they had to do. Say if we can think of a practical example. Say I am working somewhere, I am a salesman. My employer tells me that okay, you sell something for 100 rupees and you will get 5% commission. So I am selling something for 100 rupees, I get 5% commission. And so he says okay, you can keep the total amount with you for some time. So I am thinking okay, I get 100 plus 5, 105. And I am thinking if I put in the bank, how much will the bank give me interest? So the bank is giving me 8% interest. So it will be 8% of 105. So if we convert that into fractions, now 8% is a little odd fraction for this one. Let us take 10%. So first one is I am having say 100 rupees. This is the principal and the interest rate is 5%. So the fraction is 1 by 20 and the interest that I get over there is 1 by 10 of the. So this is my initial amount. This is my commission on the initial amount. So I add them. Then if I put that in the bank, this is what I am going to get as the total interest. So here I can take my B will be 1. So 100 multiplied by D plus C. So 20 plus 1, 21 and then multiplied by F plus E. So 11 divided by 20 into 10 into this will be 5, this will be 2, and this will be 21 into 11 is 2, 3, 1 divided by 2 will be 1, 1 and 5.5. 115.5 will be the total amount that I am going to get. So some examples like this we can think of while doing in the class. In fact, there is another example that these kind of problems will be, these are the examples that you left out, right sir? Yes. So using this rule, we can solve those particular examples. So this is when we have something as a principal number. To that we have to add or subtract of that fraction. We have to add or subtract of that fraction and we get a result. To that result we have to add or subtract a fraction. So percentages also can be taken here, but if we take something like 8%, it would be 8 by 100, so 108 will come. So again, if it is not a percentage that can be simplified into smaller fractions, it will result to a bigger calculation. But at least this can be time saving for many calculations like this. See to this slide for arithmetic of subtraction. Here again, the rules for addition and subtraction of fractions that is explained. Tell me, this will be okay. Addition of fractions, basically take the LCM and do it, add it. There is nothing new here. The rule for multiplication of fractions, again, what is the product of 2 and a 7 multiplied by 2 and a third of a moiety, that is half, multiplied by a third. Tell me how is filled in the method of multiplication of fractions. So here whatever we discussed in multiplication is giving some examples for solving those particular things. There is nothing new in this. I think even this can be taken up for your own practice. Rule for division of fractions, that is also the same thing. Rules for squaring or cubing or square root of cube root of fractions. So basically, how we deal with numbers, the same thing we do with, how we deal with integers, the same thing we deal with fractions. So I thought these things can be, tried out on one one. Tell me quickly, what is the square of 3.5? Square of 3.5. 3.5 square and square root of the square. So square root of the square is again 3.5. So 3.5 square, we have to do what is 3.5 square? 3 to the 6 plus 1, 7 by 2 square will be 49 by 4. What is the square root of 49 by 4? It is 7 by 2, which is nothing but 3.5. So that is, he is just giving one example for that. Same way, what is cube root of the same? Cube of the same. What is cube of this one and what is cube root of that? Will be the same thing. And then he goes to discussing about 0 or cipher. So this is what he says, like addition and subtraction by 0 is 0, multiplication by 0 is 0, square and square root of 0 is also 0, 0 square is 0, square root of 0 is 0, cube and cube root of 0 is 0, division by 0 is kahara. This is what I was saying in the initial lecture. So kahara, so he says you leave a number. So if you are dividing 3 by 0, this is called kahara, that is division by 0. So he does not say anything related to infinity or this is not defined or it is indeterminate. So all those things he does not say in this. But he discusses that further in Bijaganita. So here he mentions this as kahara. So of course he completed the text, so he must have been known like this leads to infinity, or that is how it was defined at that particular point of time. But it is not discussed in Lilavati more because this being a basic text. So I think Among the fractions, all those addition and multiplication, squaring of fractions, all those things are same. But what comes very handy and very useful is this type of thing. Like I have a principal amount, I have to add or subtract a fraction of that. Then with that result, I have to add or subtract a percentage or a fraction of that. So with this particular rule, it becomes very easy to deal with the calculus.
Can we add with 3 fractions?
No, we can go on. Can be, if you are having something like A by B, C by D, E by F, G by H, you can go on. A multiplied by D plus C multiplied by F plus E multiplied by H plus G, the whole divided by B multiplied by D multiplied by F multiplied by H. So here I will write plus or minus, because if it is minus, then minus accordingly. So this can go on and on and on for any number of summation of this, but it is not full summation. Means we are not adding. We are not adding A plus B plus C plus D plus this. We are not saying. We are adding C by D part of A by B added to A by B, and then E by F part of that added to the entire sum. Again, this is not our normal series, and then we add. We conclude here. Purnamada Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Vasishyate. Om Shanti Shanti Shanti. Hari Om Shri Gurubhyo Namaha. Hari Om.